Hi. If you check the top list of packages in Bioconductor which are about differential expression, you will see the familiar names of the top 3 for bulk RNA-seq, which is no surprise. Then some others, and then number 6 is EnhancedVolcano. That's pretty high. And if you wonder what is this EnhancedVolcano, you can click on it. Then you check the reference manual, and then you check what's in a package. It's actually EnhancedVolcano, one single plot with lots and lots of parameters. Page 1, page 2, still parameters, page 3, still a little bit of parameters, and then explanation what each parameter means. That's basically the entire package. And if you would ask what is it about Volcano, why Volcano, before you ask why enhanced, that's probably because of the shape of the mountain or the shape of the ashes flying out of the crater. And again, if you ask Google Images for volcano plot, that most of it will look like ashes flying from the crater, but sometimes it's like a mountain without any ashes. What is it? You have to know one simple thing, that there are actually two volcano plots, not one. The origin of this mountain-like volcano plot is well documented. You can read about it in this Wikipedia article Sabatier Principle, where it says that long ago French chemist Paul Sabatier suggested some ideas about heterogeneous catalysis, and then later, many years later, volcano plot was introduced by Balandin, who appeared to be a Russian scientist, died in 1967, and therefore the reference to his paper of 1969 sounds a bit fishy. It's 2 years after his death. With a little effort I could find another paper, all in Russian journal, dated 1964, where you can see his original drawings of volcano plot, and he named them literally volcano-like plots. This one and some more. The history of the second volcano plot, what we know in gene expression, is more recent, but the origin is less clear. The window for the invention of the expression volcano plot is pretty small. It could not be invented before the introduction of microarrays, which was short before year 2000. And if we check references in this publication in Wikipedia, then we see the first one dated 2001. And if you look inside that publication, scroll down and check some figures, then indeed we find the volcano plot. Pretty simple, no colors. It's actually a regular scatter plot with no extras. Also note that scales are labeled not in a way how we do it now. Was it really the very first publication where this plot was invented? It is possible. Authors do not tell it explicitly. In their mind, it was probably just an illustration, and they were busy with the more serious stuff. And at the end, it's all about V-shape. V is very likely stands for volcano, and volcano stands for V. It's either the shape of the mountain or the shape of the ashes spurted out of the mountain. And in order to appreciate this enhanced volcano, I wrote a script where I combine different volcano plots I've showed you so far. First, of course, we import libraries, ggplot, scales, for the plot. Lemma, it has many useful functions, and volcano plot. Repel is for ggplot again. Glimmer has own volcano plot, and enhanced volcano has volcano, and the DEG report as well. Then, in order to make those figures, you don't need the real data. Instead, you can simulate them. So let's make 500 data points with the standard deviation following beta distribution like this. And then we create a matrix of data, which is a sort of pseudo counts already log normed. You don't actually need counts for this script. We skip it. Then we add the gene names, and then it's all random, and therefore you would not have any significantly different genes, whatever you compare. Therefore you make them artificially. You select 10 random gene names, which is gene with a number. Some you upshift by 3, some downshift by 3. So in total it should be not more than 20 differentially expressed genes. Then you define the column names and define the groups and samples with the description what is what. And design is simply group A and B, and you will do a fit of first 3 columns to another 3 columns. So here are the gene names. So all perfectly artificial table of artificial data. Now we do a real fit. Even though the data are artificial, the fit is taken out of Lemma, and it generates the real TT table and tops. And now we check what's on the tops. Some randomly selected but differentially expressed genes. And in total there are 12 differentially expressed genes in this random simulation. It should be enough. Now we run Volcano plot out of the Lemma package. It has all the names for genes which are significantly different. So the scales are always the same. Those who do not know, log-fold change is either down or up. A minus log 10 p-value. Actually, this scale can change. It can be log 10, log 2, or other log. But inverted p-value anyway, so lower p-value, higher the position. That's how basic graphics works with Volcano plot. Then you can do yourself another graphics out of functions plot, points, and text. Let's do it. So it's also colorful with the gene names all together and the title. You can do more, but it will cost you quite some time and effort. Now we turn into a ggplot style from here to the end, more aesthetically attractive. That's pretty good, and you can show it in the papers and in the presentations, but it takes some time to write all those lines. It's pretty bulky in writing, and I hashtagged some lines because it can be even more. You can modify styles, fonts, sizes, positions. Importantly, this parameter manipulates with the number of gene names shown. Smaller number, it's less names. With a bigger number, there will be more names. Yeah, and so good, but needs some effort. Similar example of a volcano plot in ggplot style you can find on this GitHub page. And we will continue. From DEG report, it's only 4 lines. So with this plot you take only 3 columns. That's a sub-selection of TT. The whole range of genes is complete. Then you define what you will show on the plot, so it's very flexible in selecting what you want to show. And then you do a volcano, which is a bit unusual. So there is one color, but there is a colored area which you can change. In a way, aesthetically pretty good, attractive, but with some limitations. Then there is a glimmer version of Volcano where you cannot do much, but on its own it's a pretty good volcano with all the signs and titles and even the table, and there is a button to save the plot, either PNG or SVG, okay. And then finally EnhancedVolcano, which needs a bit of a zoom. So what can I say? I took only the most essential parameters over here. It is already colorful enough. There are uplines and nice fonts and the total numbers, and the title is over here as I want, and all meanings of the colors are also given. So what is enhanced in EnhancedVolcano? Of course you have to compare it with the ggplot style, and probably the whole enhancement is about your skills and abilities to go through ggplot lines by yourself, or if you find it too difficult, then you enhance your skills by calling EnhancedVolcano. That's probably the trick. It's not fundamentally different, but it's certainly complete on its own and aesthetically attractive. That's why it is so popular and stays so high in a bioconductor. That's the story.